In this video, I'm going to teach you how to solve higher order homogeneous differential equation. So let's take for example, we have 2y double prime plus 3y prime minus 2y equals 0. So this double prime means the second derivative, and this y prime is the first derivative of y. And this is an example of a higher order homogeneous um, differential equation, and we want to know the general solution of this equation. So this is homogeneous. You will know if it's homogeneous if you put all the variable y's in the left side, and the right side should be equals 0. That's for higher order differential equation. It's a different story for a first order, meaning a first derivative for y equation. So, and this is higher order because the derivative is more than the first. So it's not just simply first derivative, it's higher, it's the second derivative or more. That's why it's called higher order homogeneous differential equation. And then to solve this, we're gonna use an auxiliary equation, or we call it characteristic equation. So the y double prime is represented as r squared, so the order is represented as the exponent, and the y prime is just r to the power of 1, or just r, while the y is not it's not a derivative, it's just simply a common y. So we're gonna uh, so we're not going to use to include that as r, so because it means r to the 0. And then next thing to do is to um, find the roots of this auxiliary equation. So basically, solving the general solution of higher order differential equation is just simple. As long as you are good at algebra, then you're good at this. Unless if the given has initial problems, I mean initial values, then it's gonna be hard. It takes a longer solution, and algebra is not enough to solve it. But in this case, there's no initial values given, so it's just simple to solve. Just take the roots of the auxiliary equation. So let us factor this. We can find some factors of 2r squared, so 2r and r. For -2, we're gonna use -1 and +2. So of course, when you're factoring a quadratic equation, trinomial, you have to do trial and error. You have to keep on trying to find the perfect pair, so that when you cross multiply, you will get the middle term. In this case, the middle term is 3r. So, but in our examples, I will just use directly the correct pairing. But of course, before I did that, I made a lot of trial and errors to get the correct pairing. So to save time, I'll just put whatever is the correct pairs. So let's cross multiply. That's 2r and 2, r and -1. So r times -1 is -r, and 2r times 2 is 4r. So if you combine 4r and -r, that's positive 3r, which is correct in the middle term. And then that means that we have a correct pairing, so we will put now the factors 2r minus 1 times r plus 2. And then we're going to solve for the root. So we're going to equate the 2 by 0, because to make this equation true, that it is equal to 0, it's either the 2r minus 1 is 0, or the r plus 2 is 0, or it can be both. So we transpose the 1, so we have 2r equals 1, and divide both by 2, so r equals 1 half. And positive 2, transpose, it's -2. And since we have now the roots of our auxiliary equation, now we can write the general solution. So this is how you do it. So y equals the constant c sub 1 because there are two or more constants in this uh, given. So we'll name it c sub 1, and e to the power of, so it's always e after the constant, e to the power of the first root 1/2, and we always put x. So it's e to the raised to the power of x, but depending on the root. So if it's the root is 3, then it's 3x. If the root is 5, then it's 5x. In this case, it's 1/2, so it's 1/2 x plus then the second constant. So it's the same format. So we have the e raised to the power of the root, which is -2, and then we always put x. So we're e raised to the -2x. And that's the general solution of this differential equation. So let's try another example. We have y double prime minus 2y prime plus 2y equals 0. So the highest order is the second degree order, second order. So let's have this auxiliary equation, r squared minus 2r plus 2 equals 0. And then we are going to factor this. So let's try to find some um, factors of r squared and 2. So it's -1 and -2 because our middle is negative, so we'll try -1 times -2 is still it's +2. So if we cross multiply, you will get -1r and -2r, so the sum is -3r, and that means it's not the factor or not the correct pairing that we are looking for to make it the same -2r. I don't think we can have it. So how can we factor this r squared means 2r plus 2 if we cannot find a pairing to make it the same with the middle? So the last resort is to use a quadratic formula. So it's -b plus minus square root of b squared minus 4ac all over 2a. So this is the basic formula to find the roots of a quadratic equation. And as you can remember, this is a high school lesson, and when you're taking engineering maths, it's very important. And so I tell you, if you want to take engineering, to those students who are still in high school, as much possible you do your best for every maths that you will learn in high school, because you're gonna learn and you're gonna use it all when you reach college engineering. And so we're gonna substitute all values of a, b, and c. The b is -2, that's the middle term, and so we're gonna substitute. Also a is 1 and the c is +2. So substitute, and -2 is positive, and square of -2 is 4. 4 times 1 times 2 is 8, and 2 times 1 is 2. And then we will solve further. We subtract the 1 inside the radical sign. 4 minus 2, 4 minus 8 is -4. And then we'll continue factoring the 4 as getting the square root of 4. So we take out the 2, but then we still have a -1 inside. Square root of -1, we know that it is I, or imaginary number, and we can take out the 2, the because they have common 2, so we can take out that it outside the parentheses. So 2 times 1 plus minus I all over 2. Then we can cancel the 2, so that's 1 plus minus I. So that's the root of this uh, auxiliary equation, r squared minus 2r plus 2, 1 plus minus I. Now how are we going to write the general solution uh, if it's containing an imaginary number, meaning it's complex number? So this is how you do it. Y equals, it starts with e to raise to the power of um, e raised to the power of x. So it's x because the real number part of this complex number is 1, It's 1 plus minus I, so it's 1. That's why you put e to the raised to the power of 1x, but you don't need to write 1 in x. And then times c sub 1, which is the constant, cosine x. Now the coefficient of the imaginary is 1. That's why it's only cosine x. It's cosine 1x. Or you don't need to write 1. Plus the second constant, c sub 2, sine x. So whatever is the angle for cosine is the same as the sine. And their angle, the coefficient of x is dependent on the coefficient of the I in the imaginary part of the roots. So the real part is on the exponent of e, while the imaginary part of the complex number is on the angles of cosine and sine. So that's how you write complex roots. That's how you write general solution with involving complex roots. Now how about this? We have y double prime minus 2y prime plus y equals 0. So let's find the general solution of this differential equation. So let's write the auxiliary equation. It's r squared minus 2r plus 1 equals 0. And then we're going to find the root of this equation. So r and r, because r times r is r squared. And then we're going to choose negative 1 and negative 1. That's negative 1 times negative 1 is still positive 1. And then we cross multiply to check the pair if the pairing is correct. We is equal to negative r, and r times negative 1 is negative r. So combining the two negative r's will result to the same with the middle term, which is negative 2r. So that means our pairing is correct. So the factored form of the auxiliary equation is r minus 1 times r minus 1. Or you can write it as s squared of r minus 1. So we're gonna equate it to 0. So it's r equals 1, another r equals 1. So we have a root that is repeating. So it's a multiplicity of 2. Now how are we going to write the general solution if it's repeated? So write it this way. Y equals, so it's the same format, c sub 1 e raised to the root, which is 1 x, or you may not write 1 anymore, plus c sub 2, and it's still e raised to the x, but then we put x because it is repeated, and then e raised to the 1x, or x, because the root is also 1. So that's how you write it if it's repeated. So if it's repeated thrice, then the next one will be plus c sub 3x squared. If it's 4 times, then the next will be plus c sub 4 x cubed. Still, it's always with e raised to the x. So that's it for this example. So let's have another example. We have y double prime equals negative 4y. So you might see it like there's no 0 on the right side, but still it's an homogeneous equation because we're gonna transpose the negative 4y to the other side. So it's y double prime plus 4y equals 0. So that's a higher order homogeneous differential equation. And then we are going to change it to an auxiliary equation. So r squared plus 4 equals 0. And then we are going to transpose. We're going to solve for the r squared. So let us transpose to the other side. R squared equals negative 4. We take the square root. So the square root of a negative 4 is um, either positive 2i or negative 2i. So it contains I because the one inside the radical sign is negative. So there is an imaginary number. So the real part of this complex number is 0, and the imaginary part is 2i. And now we're going to write it in general solution form. So y equals, so e raised to the real part, which is there's nothing. It's only plus minus 2i. It means 0 plus minus 2i. So we put 0x times uh, the first constant times the cosine 2x. It's 2 because the one beside the I is 2. So this was 2x plus the c2 sine 2x. So since e raised to the 0 or any number raised to the 0 is 1, so we're going to change it to y equals c1 cos 2x plus c2 sine 2x, because 1 e raised to 0 is just 1, so you may not write it anymore. So another one, we have y double prime equals 4y. So it's just similar to the first one, although it is positive 4y. So it's still a homogeneous equation when you transpose 4y to the other side. And let's write the auxiliary equation, r squared minus 4 equals 0. But this time we have a difference of two squares where it is factorable. So we can write it this way, r squared minus 2 squared. So it's the difference of two squares, and how you factor difference of two squares, you factor it this way, r minus 2 times r plus 2. And then solve for the r minus 2 equals 0. Transpose the negative 2, it's r equals 2. And for r plus 2 equals 0, is r equals negative 2. So this is just simple, and we'll just change it to general solution. Y equals c sub 1 e raised to the first root, which is 2, so 2x, plus c sub 2 e raised to the second root, which is negative 2x. And that's it. So let's have another one. We have 36y double prime minus 36y prime plus 13y equals 0. So change it to auxiliary equation, 36r squared minus 36r plus 13 equals 0. And then we want to find the roots. So this is going to be hard to find because there are many possible factors of 36, and we're going to find perfect pairs of numbers to get a middle of negative 36. Now the closest is this, 18r times 2r, that is 36r squared, and negative 13 and negative 1, because the middle term is negative, so we expect that it's going to be negative. So if you're going to cross multiply, it will give you negative 26r and negative 18r. So if you add them, it's not negative 36r. So it is not the perfect pairs. And I don't think there is better pairing that you can do with this. So the alternative is the quadratic formula. So we'll substitute everything. The b is negative 36, a is positive 36, and c is positive 13. So we solve. Negative of negative 36 is positive 36. Square of negative 36 is 1296. Negative 4 times 36 times 13 is negative 1872. And then at the denominator, 2 times 36 is 72. Then we'll continue solving the one inside the radical sign. The result will be a negative 576. Then take the square root of 576, which is 24. So you can use calculator for that to make it easier. And then, but it is negative, so we put I, because I is square root of negative 1. And then we simplify this, taking 12, because 12 is a factor of 36 and 24, so that we can reduce into 3 plus minus 2i over 6, because 12 and 72 can be cancelled. 72 divided by 12 is 6. And then we separate the two. so that we will see the imaginary and the real number. So 3 6 plus minus 2 6I, reduce it into 1/2 plus and minus 1/3 I. Now it is a complex number, so we are going to write it in general solution form. So it's y equals, so it's always like this as I have shown for complex number, e raised to the real part, which is 1/2, so then you always put x, times c sub 1 cosine, now the imaginary part, which is 1/3, 1/3 x, plus c2 sine 1/3 x, and that's it. So that's how you write the answer if it's complex number. Now another one, we have 3y double prime plus 2y prime equals 0. So writing it in auxiliary equation, it's 3r squared plus 2r equals 0. So there's no constant, and this is easy to solve because we can just factor out the r. So it's gonna be r times 3r plus 2. And then we equate this. Of course, r is just equal to 0. And 3r plus 2 equals 0. Solve for r. It will be r equals negative 2/3. So our roots are 0 and negative 2/3. Then write the general solution. Y equals, so the c sub 1 e raised to the first root is 0, so 0x, plus c sub 2 e raised to the second root negative 2/3 x. And so let's simplify further because e raised to the 0 is just equal to 1. So y equals c sub 1 plus c sub 2 e raised to the negative 2/3 x. And that's the general solution of this differential equation. So let's have another example. 16y double prime minus 8y prime plus y equals 0. So the auxiliary equation is 16r squared minus 8r plus 1 equals 0. So let's find the roots. So let's use 4r and 4r. That's 16r squared if you multiply that. And we're going to choose negative 1 and negative 1 because the middle term is negative 8r. So probably the two factors should be negative. So let's check if this pairing is correct. Let's cross multiply. This is negative 4r and also negative 4r. So if we combine them, that's negative 8r. The pairing is correct, and we're going to write the roots 4r minus 1 times 4r minus 1. So you can write it also as square of 4r minus 1 because it's the same. So equate both by 0. So 4r minus 1 equals 0. And transpose negative 1, so it's positive 1. And then divide by 4. So the first root is 1/4. But of course, it's the same factors, so it must be the same result. So r equals 1/4 also. So it's 1/4 multiplicity of 2. Then we're going to write the general solution. Y equals c1 e raised to the first root 1/4 x plus c2. So remember, if it's repeated root, then we're going to put x then before the e raised to the 1/4 x, and that's the general solution. So let's have another example. We have y double prime plus 6y prime plus 13y equals 0. And we have some initial values given. So y of 0 equals 0 and y prime of 0 equals 2. And you're gonna need this to find the values of the constants. So if there is initial values given, then the expected answer should not be having a C1, C2, but instead the values of those constants. But first, we're gonna find the general solution. So let's use the auxiliary equation. R squared plus 6r plus 13 equals 0. And then We're gonna try to factor this into this way, and then if you cross multiply, you cannot get 6r, which is the middle term. And if you try some other pairs, it's still not possible. So because of this, we're gonna use the alternative formula, which is the quadratic formula. And so we're gonna substitute a as 1, b as 6, and c as 13. Then simplify. 6 squared is 36. 4 times 1 times 13 is 52. Then we're gonna subtract the one inside the radical sign. 36 minus 52 is negative 16. And then we get the square root of negative 16. So 6 square root of 16 is 4, and then because it's negative, we'll put I, because I is square root of negative 1. And then we will separate that into two parts, the real and the imaginary. So simplify, we reduce it, we will get negative 3. And 4 halves is 2, so it's 2i. So this is our root, and we're gonna write the general solution for this. So y equals e raised to the negative 3x because of the real part negative 3. So multiplied by the first constant times cosine of 2x, because our imaginary part is 2i, so it's cosine 2x plus sine c2 sine 2x. So this is the general solution, but we're not going to stop here because we are given with the initial values. So we're going to use the first one, y of 0 equals 0. It means if x is 0, then y is equal to 0. So if you substitute all x by 0, the y must be 0. So simplify this. E raised to the negative 3 times 0 is 0. And then for 2 times 0 is 0. That's the angle for cosine and sine. And then we will simplify further. E raised to the 0 is just 1. Any number raised to 0 is 1. And so we don't need to put that. And cosine of 0 is 1. And sine of 0 is 0. And so it becomes c sub 1 times 1 and c sub 2 times 0. So let's copy the last part because we don't have enough space, and then we'll continue. Multiplying c sub 2 times 0 is 0, and c sub 1 times 1 is just c sub 1. And that means c sub 1 equals 0. So this is the first constant, and the second constant, we're going to solve it using the first derivative. So we have this given, y equals, this is the general solution, not the given. And we're going to find the first derivative of this y. So to make it, to derive this, you can just derive it directly, or you may do it this way. You can distribute the e negative 3x before you derive. So I distribute it because anyway c sub 1 is just 0. So we can substitute c sub 1 by 0, and the whole first term will be gone because it's times 0. So we're left with e to the negative 3x c2 sine 2x. And then this is if you're going to derive this, it's gonna be using the product rule, where the u is the e negative 3x and the v is the c2 sine 2x. So if you can remember, deriving using the product rule is u times the derivative of v and v times the derivative of u, and get the sum. So first derivative of y is copy the e negative 3x and then derive the c2 sine 2x. So the derivative of sine is cosine, and that's why we have c2 cosine 2x, and then chain rule, so derive the 2x, so it's 2. Then we're gonna copy now the c2 sine 2x and get the derivative of e negative 3x. So it's the vice versa. So derivative of e negative 3x is still e negative 3x, but take the derivative of negative 3x, which is negative 3 because of chain rule. Then we're gonna copy because we don't have enough space, and then we'll continue simplifying this. So since based on the given in the initial values, if x is 0, then the first derivative of y is 2. And then we're gonna substitute it here. So let's simplify further. So 2 equals e raised to the 0, and then the 2 times 0 for cosine is 0, 2 times 0 for the sine angle is 0, and e to the negative 3 times 0 is e to the raise e to the 0, and we're gonna continue simplifying. So we're left with e to the 0 as 1, and cosine 0 is 1, and sine 0 is 0, and e raised to the 0 is 1. Then since the term c sub 2 times 0 times 1 times negative 3 contains 0, so it will be gone because it's times 0. And then let's multiply this term, so it will become c sub 2 times 2, and dividing by 2 both sides will be c sub 2 equals 1. So we have a value now of c sub 2. And so let's go back to the general solution and we will substitute. So we know that c sub 1 is 0 and c sub 2 is 1, so we'll substitute. Then let's copy first the last part because we don't have enough space, and then continue 0 times cosine 2x is 0, and so our final answer will be y equals e raised to the negative 3x sine 2x. That is the final answer. So let's have another one. So here we have actually exactly the same as the previous one. Y double prime plus 6y prime plus 13y equals 0. Except for the initial values, we have y of 0 equals 2, and the first derivative of 0 is equal to 1. The first derivative of y of 0 is equal to 1. So we're gonna have the general solution directly because it's the same as the previous example, and our concern is to find the constants. So substitute. If x is 0, y is 2 based on the first initial values. So we're gonna substitute all x by 0 and y to 2. So let's simplify e raised to the 0, and for the angle of cosine and sine, it's 2 times 0 is 0. Then e raised to the 0 is 1, cosine of 0 is 1, and sine of 0 is 0. And so since c sub 2 is times 0 is just 0, so it's gone. And what's left is c sub 1 times 1, which is c sub 1. That means our c1 is 2. Now let's find the second term using the first derivative. So that means we're gonna derive our the general solution, but instead of c sub 1, we're gonna change it to 2 because we already solved it. So it's now 2 cos 2x. So we're gonna do product rule where our u is e negative 3x and our v is 2 cos 2x c2 sine 2x. So here's the first derivative. We copy the e negative 3x, and derive the second part, the 2 cos 2x plus c2 sine 2x. So derivative of cosine is negative sine, and derivative of sine is cosine. Then we will copy the second part, and we will derive the first part, the e negative 3x. So deriving e negative 3x is still e negative 3x times the derivative of the exponent. So it's negative 3. So let's copy the first derivative because we don't have enough space, and then now we are going to continue. So substitute based on the given. If x is 0, then the first derivative of y is 1. So substituting it all, then we will simplify uh, the, the expression, the equation. So e raised to the negative 3 times 0 is just e raised to the 0. And then for the angles, 2 times 0 is 0. So all the angles will become 0. And then e raised to the negative 3 times 0 becomes e raised to the power of 0. Then we will continue with e raised to the power of 0 is 1. Any number to the power of 0 is 1. Then we're gonna change each sign of 0 is into 0, and also each cosine 0 into 1. Then we're gonna solve further. So 1 times negative 4 times 0. So negative 4 times 0 is 0. So we're left with 2c sub 2. And also c sub 2 times 0 is 0. So we're left with positive 2. And 1 times negative 3 is negative 3. Then solving further, 1 times 2c sub 2 is 2c sub 2 plus 2 times negative 3. So let's copy the last part and continue solving. 2 times negative 3 is negative 6. And so we will transpose negative 6. It will be 6, and it's 1 plus 6 is 7. So dividing both sides is 7 halves. So c sub 2 is 7 halves. Now we'll go back to our general solution and let's substitute. So the final answer will be y equals e to the negative 3x times the c sub 1, which is 2 cosine 2x, plus c sub 2 is 7 halves sine 2x. Now we'll have another example with an initial value problem. And then we're going to have the auxiliary equation r squared plus 6r plus 9. So we can factor this. This is factorable as 3 and 3. If we cross multiply that, that will be 3r and 3r. Combining 3r's will be 6r. So this is a correct pairing. So the factored form is r plus 3 and r plus 3. So solving for r, it will be r equals negative 3. Since it's the same, so it's going to be the same root. So it's a repeated root. Then we're going to have the general solution y equals c sub 1 e raised to the negative 3x, because that's the root, plus, because it's repeated, so it's going to be c sub 2x e raised to the negative 3x. So that's the general solution. And now our problem is to find the values of the constants. So let's copy the last part. We have y equals c sub 1 e raised to the negative 3x, the c sub 2x e raised to the negative 3x. And that's the general form, general solution. And we're going to substitute based on the given. If x is 0, then y equals 1. That's the given initial value. Then since the second term contains 0, as x, so it will be gone. C sub 2 times 0 is 0. So we are left with the first term. And let's simplify further. E raised to the 0 is 1, so you will not write it anymore. That means our C sub 1 is 1. Then to find the second constant, we need to find the first derivative of y. So this is the y, where we change the C sub 1 into 1 because it is already solved. And it will become like this. So there's no problem with the first term. Getting the derivative of e negative 3x is just the same. But for the second term, we need to do the product rule, where our u is c sub 2x and our v is e negative 3x. So let's get the first derivative. Derivative of e negative 3x is e negative 3x times negative 3. Derivative of the two expressions using the product rule, we're gonna copy first the c2x and then get the derivative of e negative 3x, which is e negative 3x times negative 3. And then plus, copy the e negative 3x and derive the c2x. So the derivative of c sub 2x is just c sub 2 because derivative of x will be 1. So it's gone. So this is the first derivative. So let's copy the first derivative and we're going to substitute based on the given. So based on the given, if x is 0, then the first derivative of y is 2. And then we're going to simplify further. Negative 3 times 0 is 0. And now, since c sub 2 times 0 contains 0, so this whole term will become 0. Then let's continue. E raised to the 0 is 1. And 0 will be gone. So we're left with this. 1 times negative 3 is negative 3. 1 times c sub 2 is c sub 2. Then we'll transpose negative 3, so 2 plus 3 is 5. So that is our second constant. So since we have the two values of these constants, then we'll substitute. So c sub 1 is 1 and c sub 2 is 5. So our final answer will be y equals e to the negative 3x plus 5x e raised to the negative 3x. So let's have another example. We have y triple prime plus 3.2 y double prime plus 4.81 y prime equals 0. And we are given with these initial values. Y of 0 equals 3.4, y prime of 0 equals negative 4.6, and y double prime of 0 equals 9.91. So this is gonna be hard because first it is at third order differential equation, and second is it contains decimals, and it makes it harder to solve, especially when you are going to factor and also when you're going to find the derivatives. So let us try to solve this. So if it's gonna be resulting to a complex roots, then it's gonna be way harder. Unlike to just simply get a root which is real, that's not gonna be containing a cosine and a sine. But if it's complex, meaning it's containing I in the root, then that's gonna be hard. So let's try to solve this. We have the auxiliary equation, and the r is common. We can factor the r, factor out r, so we are left with r squared plus 3.2r plus 4.81. And then we're gonna factor this, but it's gonna be hard for us to use factoring with the cross multiplication, and because it contains decimals and it's hard for us to find pairs of 4.81 to get a sum of 3.2. So we'll just use a quadratic formula where the a is 1, the b is 3.2, and the c is 4.81. And so 3.2 squared is 10.24 minus 4 times 1 times 4.81 is 19.24. And then we're going to subtract. We have square root of negative 9. So square root of negative 9 is 3i. So separating this into two parts, we'll have negative 2.2 halves plus minus 3 halves I. Divide 3.2 by 2 is negative 1.6. 3 divided by 2 is 1.5. So this is our root, and fortunately it is complex. It's complex numbers, so we're gonna have a sine and cosine. It's gonna be surely it's gonna be a long solution. So let's have the general solution. And by the way, since we have a factor r, so that means one of the roots is 0. So y equals c sub 1 e raised to the 0 x, that's for the r equals 0. Now for the complex roots, we have e raised to the negative 1.6x, that's for the real part, times cosine c sub 2 cosine of 1.5x, 1.5 because of the imaginary part, 1.5i, plus c sub 3 sine 1.5x. So let's remove the e raised to the 0x because it's raised to the 0, so it's just same as 1. So we're left with the c sub 1. So this is the general solution, and our aim is to find the c sub 1, c sub 2, and c sub 3. So let's copy the general solution, and then we're gonna use the given values to find the value of c sub 1, c sub 2, and c sub 3. So it's given that when x is 0, y is 3.4. So substitute it all and simplify further. So e raised to the negative 1.6 times 0 will become e raised to the 0. And cosine of 1.5 times 0 will become cosine 0, the same as for the sine. Then e raised to the 0 is just the same as 1, cosine of 0 is 1, and sine of 0 is 0. And then we will multiply. So since c sub 3 times 0 is 0, then we can just remove that. So we're left with c sub 1 and c sub 2. So this is the equation that we have created. Unfortunately, we cannot have a value, but we can have that later. So for now, it's just an equation, c sub 1 plus c sub 2 equals 3.4. And then we'll continue with the given with the general solution that we have, and then we are going to get the first derivative. So the first derivative of c sub 1 is 0 because it's constant. So derivative of a constant is 0. Now we just need to find the derivative of the second term, the one with e negative 1.6x, that is our u, because we're going to use a product rule. And our v is c2 cos 1.5x plus c3 sine 1.5x. So first is we're going to copy the e negative 1.6x and get the derivative of the blue part, the one that I colored blue. So the derivative of cosine is negative sine. That's why it becomes negative c sub 2 sine 1.5x times 1.5 times 1.5 because we take the derivative of the angle. That's according to chain rule. Next is the derivative of sine is cosine. So c sub 3 cosine 1.5x times 1.5. And then plus, so the vice versa. So we'll copy the blue colored part, the c sub 2 cosine 1.5x plus c sub 3 sine 1.5x. So we'll just copy that, and then we'll take the derivative of e negative 1.6x. So the derivative of that is also e to the negative 1.6x times the derivative of the exponent, which is negative 1.6. So this is our first derivative, and now we're going to substitute. So based on the given, if x is 0, then the y prime is negative 4.6. And so let's continue solving. So e raised to the negative 1.6 times 0 multiplied by 0 is 0. So it becomes e raised to the 0. And also for the angles of cosine and sine, so it's 1.5 times 0 is 0. So everything will become 0. Then let's continue. We have e raised to the 0 becomes 1, and every sine of 0 is 0, and also every cosine of 0 is 1. And then negative 1.5 c sub 2 times 0 will be gone because it's times 0. The same as the c sub 3 times 0, because it is multiplied by 0, it becomes 0. And you can remove now all the times 1. Then, so we'll remove the zeros and we will multiply negative 1.6 by c sub 2. And so, this is our second equation, so we'll just arrange it in order of c of the constant. So negative 1.6 c sub 2 plus 1.5 c sub 3. And so this is our first derivative, and then we need to find the second derivative. Now to make it easier for us to find the second derivative, we will just distribute the we are going to factor out e negative 1.6x because that's common to both terms, and we are going to distribute negative 1.6 so that it looks easier to solve using finding the second derivative. So we factor out e negative 1.6x, and also the one inside the parenthesis, which is containing a times 1.5, we put it at the side of each constant so that it will not be mistakenly multiplied to the angle of the sine and cosine. So that's why the 1.5 is transferred at the side of c sub 2. It's now negative 1.5 c sub 2. The same as for the rest of the terms. So it becomes 1.5 c sub 3. And also the negative 1.6 is distributed into negative 1.6 c sub 2, negative 1.6 c sub 3. So let's copy the first derivative of y, or the y prime. Then we're gonna get the second derivative. So we color the u as red, it's e negative 1.6x, and the v as the blue, so that it's easier for you to use the product rule, and you will not get confused. Where's the u, where's the v? So let's get the second derivative. Copy the e negative 1.6x and then derive the blue one. So the derivative of sine is cosine, so it becomes cosine, and then the derivative of cosine is sine, so a negative sign. So every cosine, if you derive it, it will change sign into negative. And so we have 1.5, negative 1.5 c sub 3 sine 1.5x times 1.5. And then derivative of cosine is negative sign. So it changes from negative 1.6 into positive 1.6 c sub 2 sine 1.5x. times 1.5. There is always 1 point times 1.5 because of the chain rule. Because you need to find the derivative of the angle inside the sine or the cosine. Then last is derivative of sine is cosine. So the sine of negative 1.6 will remain into negative. And the next part is plus. So we're gonna copy the whole blue part and then derive the e negative 1.6x, which is the same as e negative 1.6x, but times the derivative of the exponent, which is negative 1.6. Then let's simplify further. So we're gonna multiply every 1.5 to the coefficient of the constant. So 1.5 times negative 1.5 is negative 2.25. And also 1.5 times 1.6 is 2.4. So for, what I'm talking about the green one. And for the blue ones, it's the same uh, because there's nothing to multiply. And that's it. That's the second derivative when you simplify it. So let's copy the one that we have simplified and then we're gonna continue. So what we did is we distribute the negative 1.6 in the last part. So we distribute it. So the negative 1.6 is multiplied to negative 1.5. It becomes 2.4. And it is also distributed to 1.6 itself. So 1.6 times 1.6 is 2.56. So that, but the rest is just copied. And then what we did here is we take out the e negative 1.6x. So everything is just copied except that the e negative to the power of negative 1.6x is factored out. That's why you only have one left, e negative 1.6x. So this is the last part, and then we are going to uh, put colors to the like terms so that it's gonna be simpler to solve. It's gonna be lesser terms. So I put color on those with the same c sub 2 and cosine 1.5x because you can only add or subtract them if they are having the same constant, the same trigonometric function. They must be the same cosine and they must be the same angle. So we have C2 cosine 1.5x colored as yellow. We have C3 sine 1.5x colored as violet. And C2 sine 1.5x is colored as a lighter blue, sky blue. And C3 cosine 1.5x, I color it as yellow green. So through that, it's easier for you to look at what are the like terms. And then we're going to combine these like terms. So negative 2.25 and positive 2.56 is 0.31. And negative 2.25 and 2.56, combining that, we will have 0.31. And 2.4 and 2.4 will resolve to 4.8. So it's the same for the sky blue and the yellow green. It's 4.8, positive and negative. So we copy the last part and then we're gonna substitute based on the y double prime. So if x is 0, the y double prime is 9.91. So we substitute it all and then we're gonna continue simplifying. The e negative 1.6 times 0 will become e raised to the power of 0. And then the angles, every angle becomes 0 because 1.5 times 0 is 0. And then cosine 0, every cosine of 0 is 1, and every sine of 0 becomes 0. And e raised to the 0 is 1, because any number raised to 0 is 1. So 1 will be gone. So 0.31 c sub 2 times 1 is just itself, but every term that is times 0 will become 0. So we're left with two, uh, two constants, the c sub 2 and the c sub 3. So this is another equation that we're going to use later to find the values of the constants. So we're going to collect all the equations that we have. 3.4 equals c sub 1 plus c sub 2. That's the first one. The second one is negative 4.6 equals negative 1.6 sub 2 plus 1.5 c sub 3. The next one, the last one that we solved, is 9.91 equals 0.31 c sub 2 minus 4.8 c sub 3. So we're going to find the constants by using simultaneous equation. So there are, if you can remember, that is actually a grade 8 lesson. We're going to use elimination method, but you can use any uh, ways of solving as long as you can get the values of C1, C2, and C3. So I'm gonna pair the blue and the violet because they both have C2 and C3, and I want to eliminate the C3, so I'm gonna multiply both by the opposites. So 1.5 will be multiplied by 4.8, and 4.8 will be multiplied by 1.5, so that both coefficients will be the same, and if you combine them it becomes 0. So here's the result. If you distribute the 4.8 it will be like this, and if you distribute the 1.5 it's gonna be this, using your calculator of course, so to save time. So observe that the C3 contains the same number with opposite signs, so that's intended so that it's gonna be gone. So let's combine. It will result in negative 7.215 equals negative 7.215 c sub 2. And so it's amazing that we have decimals, and then we'll come up with the same number, the same decimal. So if you divide both sides by negative 7.215, you'll get 1. So c sub 2 equals 1. So since we know that c sub 2 equals 1, so we're going to use the orange equation, and we'll substitute c sub 2 into 1. And then we're going to transpose 3.4 minus 1 is 2.4. So that means c sub 1 is 2.4. And then we can use either of these two equations, the blue and the violet, to find the c sub 3. But in my case, I'm going to use both, so that this is one way to check if you are doing it correctly, if you have the correct answer. Because it's hard for us to review all the solutions. It's very long solution, and it's very messy, and it's hard for us to find the wrong solution. So this is one way to check if you are doing it correctly. So let us substitute. We have C2 is 1, so change it to 1. So it's negative 1.6, and we're gonna transpose it. So negative 4.6 plus 1.6 is negative 3. Divided both by 1.5, c sub 3 is negative 2. Now we're gonna solve also in the other equation. It must result to c sub 3 equals negative 2. If it's not, then that means there is something wrong in your solution. You may not know where is that mistake, but at least you know that there is something wrong, that you have committed a mistake in your solution. That means you have to go back from the start. I'm not saying that you're gonna solve again, but you just go back to from the start and find where is the mistake. You have to trace it. So that's why this is very important, that you need to solve both so that you can check if it's correct. So let's change c sub 2 into 1, and then of course any number times 1 is itself, and then transpose 0.31, so it will be subtracted to 9.91, so it results to 9.6. Then divide both sides by negative 4.8, it's gonna be negative 2. So as you can see, it's the same result. That means we are having a correct value. So I am 99% sure that the values of our constants are correct. So I'm saying 99% because there is 1% chance that it is just a coincidence that it's correct value, but it's the same answer to both equations, but the constant is wrong. So it may be a coincidence, but it's 99% sure that you are doing it correctly. So let's go back to our original uh, equation. So we're gonna change every constant to our value solved. C1 is 2.4, C2 is 1, and C3 is negative 2. So we'll just remove the 1 and we have the final answer. Y equals 2.4 plus e raised to the negative 1.6x times cosine 1.5x minus 2 sine 1.5x. So let's have an example. So this time it's gonna be at the fourth order differential equation. So we have y to the fourth, we have 4 primes minus 9y double primes minus 400y equals 0. And then we have initial values from y up to the y triple primes. And so we're gonna have the auxiliary equation r to the fourth minus 9r squared minus 400 equals 0. And so we're gonna factor this r to the fourth as r squared and r squared. And for the negative 400, so we're gonna do trial and error until you get, if you cross multiply, you get a sum of negative 9. And so we have negative 25 and 16, because if you cross multiply that, it will be negative 25 r squared and 16 r squared. And also negative 25 times 16, it must be negative 400. And so since it is correct, if you get the sum of the two will be negative 9r squared, so the pairing is correct. It will be r squared minus 25 times r squared plus 16. And so we're gonna factor the r squared minus 25, it's difference of two squares, r minus 5 times r plus 5. But r squared plus 16, you cannot factor that because it is not difference, it is sum, r squared plus 16. But still you can get the value for r. So r minus 5 equals 0 is r equals 5. R plus 5 equals 0 is is negative 5. R squared plus 16 transpose, it will be r squared equals negative 16. And then take the square root of both sides. You will have r equals plus and minus 4i. So it contains I because it's negative. And so we have these roots, and we can have now the general solution. So y equals c sub 1 e raised to the first root, which is 5, so 5x, plus c sub 2 e raised to the second root, which is negative 5, negative 5x, plus now it's complex, so the third and the fourth root is part of the complex number. So we're gonna follow the format for complex roots. So e raised to the 0x, because there's no real part, times c sub 3 cosine of 4x, because it's 4i, so the angle will be 4x, plus c sub 4 sine 4x. So this is the general solution, and we're gonna find the constant of this equation. So to do that, we're gonna um, substitute. So since e raised to the 0x, by the way, is 1, so you may remove that. So substitute the given equation. It was given that y of 0 is 0, so it means if x is 0, we're gonna change the y to 0. So substitute, it will become c sub 1 e raised to the 0, and so everything that is times 0 will become 0, and then e raised to the 0 is 1, and cosine of 0 is 1, and sine of 0 is 0. Then simplify further, we have 0 equals c sub 1 plus c sub 2 plus c sub 3. So this is the y, and now we want to know the first derivative so that we can create another equation. So the first derivative, you get each term, we're going to derive each term. So e raised to the 5x times 5, that's the derivative of e raised to the 5x. Derivative of e to the negative 5x is e to the negative 5x times negative 5. Derivative of cosine is negative sine. Derivative of sine is positive cosine. Then we are going to arrange numbers. The times 5, we're going to put it beside a constant. And also the negative 5, we're going to put it beside the c sub 2. Also the 4, we're going to put it beside of c sub 3. And 4, we're going to put it in the c sub 4. So it's actually the same as the green one, but it's better that you arrange it to avoid committing some mistakes. Then we'll substitute. It was given that for if x is 0, then the y prime is 0. So we'll substitute, and 5 times 0 is 0, negative 5 times 0 is 0, and the angles, so every number multiplied by 0 becomes 0. And then we'll change e raised to the 0 into 1, and sine of 0 is 0, cosine of 0 is 1. And then multiply by 1 is just itself, and the negative 4 c sub 3 times 0 will be gone because it's times 0. So we have created another equation where we're going to use it later to using elimination method to find its constants. So this was the first derivative, and we're going to find the second derivative out of this. So the second derivative, get the derivative of each term. E raised to the 5x is e raised to the 5x times 5. So it's actually the same procedure for e, but for the cosine and sine. So derivative of sine is cosine, and derivative of cosine is negative sine. And then so the times 5 that came out because of the chain rule. So we're gonna times it. 5 times 5 is 25. Negative 5 times negative 5 is positive 25. 4 times negative 4 is negative 16. So to both cosine and sine. And then we are going to substitute based on the given initial value. If x is 0, then the y double prime is 41. And so um, let us simplify this. Every number multiplied by 0 becomes 0. And then e raised to the 0 becomes 1. Cosine of 0 becomes 1. Sine of 0 becomes 0. And so negative 16 c sub 4 times 0 will be gone because it's times 0. So this is another equation we have created. So this is the second derivative, and we want to find the third derivative out of this. So the third derivative, so it's the same procedure. We get the e raised to the 5x So the derivative of that is just itself times the derivative of the exponent. The same as well as the e to the negative 5x. And for the cosine and sine, derivative of cosine is negative sine, so the negative 16 becomes positive 16. But for sine, derivative of sine is just cosine, so the sine of negative 16 will remain. And then we're going to multiply each constant. 5 times 25 is 125. Negative 5 times 25 is negative 125. 4 times 16 is 64. 4 times negative 16 is negative 64. And that is the third derivative. And then we're going to substitute based on the given. If x is 0, then the y triple prime is 0. So we substitute, and we're going to multiply every number multiplied by 0 becomes 0. So 5 times 0 is 0, and so on. Then e raised to the 0 becomes 1, sine of 0 is 0, cosine of 0 is 1. Then multiply. So any number multiplied by itself is by 1 is just itself. But for 64 c sub 3 times 0, it's gone because it's multiplied by 0. So this is another equation we have created. So let's collect all the equations that we have come up, and I'm going to put different colors to for that it's easier for us to refer which equation where I'm talking about. And so we're going to use simultaneous equation method. I'm going to use elimination to find the C1 up to C4 constants. So I'm going to pair this is the red equation and the violet equation. I prefer to pair this because they have the same constants, C1, C2, and C3. And also we can pair the green and the violet because green and blue because they have the same um, constant C1, C2, and C4. So we're gonna do that later. So for now, let's do this. So I'm going to multiply this by negative 25 so that the C1 and C2 will be gone. So distribute the negative 25 and let's combine. So 0 plus 41 is 41. And the C1 C2 will be gone because it's the same number with opposite signs. It will be 0. And negative 25 minus 16 is negative 41. So let's copy it and divide both by negative 41. It will result to C3 equals negative 1. So that's our value for C sub 3. Now we're gonna use this the green and the blue as I said because they contain the same constants C1, C2, and C4. And I'm going to multiply the first equation by negative 25 so that the C1 and C2 will be gone. So negative 125 C sub 1. So by the way, negative 25 times 0 is 0. So negative 25 times 5 is negative 125. And negative 25 times negative 5 is positive 125. Negative 25 times positive 4 is negative 100. And then let's copy the second equation. Then combine. So the C1, C2 will be 0. And we're left with the C sub 4. Negative 100 and negative 64 becomes negative 164. But since the left side of the equation is 0, so anyway, any number divided 0 divided by any number is 0. So dividing both sides by negative 164 will still result to 0. So C sub 4 is 0. So now we're gonna use these two equations because we're given with the C3 and we're given with the C4. So that means we're left with C1 and C2. So C3 is negative 1 and C4 is 0. Now let's transpose the negative 1. It becomes positive 1. And 4 times 0 is 0. It's gone. Now we are going to multiply the first equation by 5 so that the C2 will be gone. So let's copy and then combine. So 5 plus 0 is 5, 5 plus 5 is 10, so it's 10C1. But 5 plus negative 5 is 0. So dividing both by 10, C1 is 1 half. So we have already C1. So now we can find the C2 with this either of these two equations, or we can actually use 3. So anyway, 2 is enough. So we're gonna solve either of these two equations, but as I said, if it's possible to solve two equations, you must solve both so that you can check if you're getting the answers correctly. And so if these two equations are having the same answer, that means you're doing it correctly. So let's substitute. C1 is 1 half, C4 is 0. So 5 times 1 half is 5 halves. Then 4 times 0 is 0, so it's gone. Then transpose, 5 halves becomes negative 5 halves. Then divide both sides with negative 5. So C sub 2 is 1 half. So the C sub 2 must be also 1 half when you solve the violet. So C sub 1 is 1 half and C sub 3 is negative 1. And so 25 times 1 half is 25 halves. Negative 16 times negative 1 is positive 16. Then transpose everything except for the term with the C2 and change signs when you transpose. So subtract them, it will result to 25 halves. Then divide both by 25, C2 is 1 half. So this is having the same result. So we are at least 99% sure that we are doing it correctly, that there's no mistake in the rest of the previous solutions that we had. So 1 half is C1. C1 is 1 half, C2 is 1 half, C3 is negative 1, and C4 is 0. So we have all values of the constants that we needed. And so let's go back to our general solution, and we're gonna change each constant by the values. So C1 is 1 half, C2 is 1 half, C3 is negative 1, and C4 is 0. So the final answer is y equals 1 half e raised to the 5x plus 1 half e raised to the negative 5x minus cosine 4x, and the sine 4x will be gone because it is times 0. So let's have another one. So this will be the last example. We have up to the 5th degree differential equations. It's a 5th order differential equation. Y to the 5 primes minus 5y triple primes plus 4y prime equals 0. And we are given with a bunch of initial values from y up to the y to the 4 primes. And then we're gonna use the auxiliary equation r to the 5th minus 5r cubed plus 4r equals 0. We want to find um, the general solution of this. So we need the roots to find the general solution. So take out the r because r is common, and we need to factor this. R to the 4th is r squared and r squared. For 4, negative 4, and negative 1. Cross multiply to check we are doing it correctly. Negative 4r squared and negative r squared. If you combine them, that's the middle term, negative 5r squared. So our pairing is correct. So the factors are r squared minus 4 and r squared minus 1. And so if we factor it completely, where the r, including the r that we have factored out, so it's all r times r minus 4, r plus 4, r minus 1, r plus 1, because of difference of two squares. And then we'll solve for every r equals 0, r equals 4, r equals negative 4, r equals 1, and r equals negative 1. So we have 5 roots because it's fifth degree. And then we're going to find the general solution. So for r equals 0, c1 e raised to the 0x. For r equals 4, c2 a raised to the 4x. For r equals negative 4, c3 e raised to the negative 4x. For r equals 1, c4 e raised to the x. And for r equals negative 1, c5 e raised to the negative x. And we'll just remove the e raised to the 0 because it's just 1. So this is the y, the general solution. And we can use this to substitute uh, where there is given y of 0 equals 3. So let's copy it and let us substitute. If x is 0, then y is 3. So every x is changed into 0 and all the numbers multiplied by 0 becomes 0. So every e raised to the 0 becomes 1. So every e will be gone because it all becomes 1. And here's the first equation. 3 equals c1 plus c2 plus c3 plus c4 plus c5. So now we'll go back to this because we need to find the first derivative. So the first derivative of this y is the derivative of c1 is, since it's constant, derivative of any constant is 0. So it's gone, c1 is gone. So derivative of c2 e raised to the 4x is just itself times the derivative of the exponent, which is 4. The same as for the c3 e raised to the negative 4x, it's just itself times the derivative of the exponent negative 4x, which is negative 4. Then c4 e raised to the x, the derivative of that is just itself times derivative of x, which is 1. Then c5 e raised to the negative x is just itself times the derivative of negative x is negative 1. So we're going to arrange it, put all the constants beside the constants. So 4c2, the negative 4c3, and 1 times c4 is just c4, so you don't need to put 1. The same as the negative 1. But we're going to change the plus into minus because it's negative. So that's the first derivative, and we're going to substitute. So based on the given, so if x is 0, then the y prime is negative 5. So we're going to change every x into 0. And then all the numbers multiplied by 0 will be 0. And all the e raised to the 0, any number raised to the 0 is 1. So e raised to the 0 becomes 1. And so we're left with this equation. Negative 5 equals 4c sub 2 minus 4c sub 3 plus c sub 4 minus c sub 5. So we're going to use this later to solve for each constant. Then let's copy the first derivative and we're going to find the second derivative. So here's the second derivative. So it's actually the same procedure like the first derivative, getting the derivative of every e to the raised to the x. It's just itself, but you need to get the derivative of the exponent and you're gonna multiply it. So it's the same procedure for each term, and I will not discuss it anymore to save time. And we'll multiply. 4 times 4 is 16. Then negative 4 times negative 4 is positive 16. 1 times c4 is just itself. And negative 1 times negative c5 becomes positive c5. So this is the second derivative. And we are going to substitute based on the given initial value. According to the given, if x is 0, then the y double prime is 11. So let's multiply the numbers. So for every number multiplied by 0 becomes 0. And then all the e to the raised to the 0 becomes 1. So we're left with this equation. So still we're gonna keep this because we need this for the for finding the values of the constants. So this is the second derivative, and we're going to find the third derivative. So again, the same procedure. So everything will be the same except that the constants are having getting bigger and bigger coefficient. So it's now 16c2 and 16c3. Then let's multiply. 4 times 16 is 64. Negative 4 times 16 is negative 64. 1 times c4 is just 1, and negative 1 times c5 is negative c5. Then let's substitute based on the given. If x is 0, then the y triple prime is negative 23. That was the given initial value. So let's multiply the numbers by 0 becomes 0, and then every e raised to the 0 becomes 1. So this is another equation that we needed. So here's the y triple primes, and then we're gonna use this to find the y with 4 primes, or the fourth derivative of y. So it's actually the same procedure because it's just e raised to the of x. So when getting the derivative of that, it's gonna be itself times the derivative of the exponent. So that's why it's easier to do. Except that the coefficient of c2 and c3 is getting bigger and bigger. And so we're gonna continue. Multiply 4 times 64 is 256. Negative 4 times negative 64 is 256. 1 times c4 is c4, and negative 1 times negative c5 is positive c5. So this is the fourth derivative of y. And now we're gonna substitute. So based on the given initial value, if x is 0, then y to the fourth prime is 47. And so e raised to the 0 becomes 1, so it's gone. And we're left with this. And we're gonna need this later. So let us gather all the equations that we have come up. We have this equation 3 equals c1 plus c2 plus 3t plus 3 4 plus c5. That's the first one. That's the first equation that we got. Then the next one, it was negative 5 equals 4c2 minus 4c3 plus c4 minus c5. And then we also got 11 equals 16c2 plus 16c3 plus c4 plus c5. Then we have this negative 23 equals 64c2 minus 64c3 plus c4 minus c5. And we also have this 47 equals 256c2 plus 256c3 plus c4 plus c5. That is actually the last equation that we got. And then I'm gonna pair these two, the the yellow green and the royal blue equation, because as we observed, they have the same it's the same c2 and c3, because it's a multiple of 4. 64 is a multiple of 4, so I can make it easily the same. So I can just multiply the first equation by negative 16, so it's going to be the same 64. So I distribute negative 16, so we have this. And then let's combine. So the c2 and c3 will be gone. So 80 minus 23 is 57. Negative 16 plus 1 is negative 15, so it's negative 15c4. Also 16 minus 1 is 15, so it's 15c5. So this is another equation that we have come up. So although we haven't get a value of a constant, but at least we are getting us lesser and lesser variables in an equation. It's only c4 and c5. Now I want to pair the violet and the orange equation, because if I'm going to multiply negative 16 to the violet, then it's gonna be the c2 and c3 will be gone. So I just multiply it by negative 16, and so it will result to this if you distribute negative 16 and copy the orange. And let's combine this. So negative 176 times plus 47 is negative 129. Negative 16 plus 1 is negative 15 for both C4 and C5. But for C2 and C3, since it's exactly the same number with opposite signs, it will be 0. So it is like this. Negative 129 equals negative 15C4 minus 15C5. And then I'm gonna pair this with the previous one that I have come up. 57 equals negative 15C4 plus 15C5. So you can just combine this directly because C5 can be gone. So let's combine. Negative 72 equals negative 30C4. Divide both by negative 30. C4 is 12 fifths. Now we have one value of a constant. So the constant C4 is 12 fifths. So we're going to use this again to find the C5 since we know the C4. Either of the two equations can come up with the value of C5. But again, we're going to use both so that to check if we are doing it correctly, that C4 is really equal to 12 fifths. So change a C4 into 12 fifths. Let's solve first the yellow-green colored equation. And so we're gonna reduce 15 and 5, that's 3. 3 times 12 is 36. And then transpose negative 36, it becomes positive 36. And then combining negative 129 and 36, negative 93. Then divide both by negative 15. So C5 is 31 fifths. Now we're gonna do the same to the orange equation, and the result must be the same, 31 fifths. So we change C4 to 12 fifths. Again, cancel 15 and 5, it's 3. So 3 times 12 is 36. And then we transpose. So 57 plus 36 is 93. Divide by 15 both sides, so it's 31 over 5. So this means our C5 is really 31 fifths. Now this time I'm gonna pair the violet and the blue one, the blue equation, because C4 and C5 are given. So let's change the C4 and C5 to both equations, 12 fifths and 31 fifths. Then we are going to transpose to both equations and then combine. It's 12 fifths equals 16C2 plus 16C3. And also for the blue, it becomes negative 96 fifths equals 64C2 minus 64C3. And so we want to eliminate C3. So we will times the violet by 4 so that the C3 will be gone. So distribute the 4, becomes 48 fifths equals 64C2 plus 64C3. Copy the blue. Then combine, so the C3 will be gone. So the result will be negative 48 fifths equals 128 C2. So let's copy and then divide both by 128 to get the C2. So C2 is negative 3 over 40. And now since we know that C2 is negative 3 over 40, so we're going to use these two equations to get the C3. And also to make sure that we are having it correct solution. So it must be the same answer. So let's change C2 into negative 3 over 40. So this will become negative 6 fifths. So you use calculator to make it accurately. And then transpose negative 6 fifths. And then combine. So it will be 18 halves equals 16C3. Then divide both by 16. It will result to C3 equals 9 over 40. And it must be C3 equals 9 over 40 for the blue ones. So let us check. So negative 3 over 40, that is the C2. And then multiply, it will give you negative 24 over 5. And transpose, it will be positive 24 over 5. And then you combine, it will result in negative 72 over 5. Then divide both by negative 64, it will be C3 equals 9 over 40. So we are sure that we are doing it correctly. C3 is 9 over 40. And then let's go back to this equation, the first one. Since we know the C2, 3, and 4 and 5, so let's substitute it all. And then we're going to transpose it all to the other side and combine. It will result to C1 equals negative 23 over 4. Now since we have it all, C1, C2, C3, C4, and C5, now let's go back to the original general solution and substitute whatever constant values. So y equals negative 23 over 4 minus 3 over 40 e to the 4x plus 9 over 40 e raised to the negative 4x plus 12 fifths e raised to the x plus 31 over 5 e raised to the negative x. And that is the final answer. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button. And also, write the math topics you want to learn in the comment section.